Okay, so imagine you have a lot of lights in your game. The game has feature lighting on, and it's a problem when you go to play a game, or when any other player tries to play a game that you're friends with. Your friend tries to play a game, they experience lag. So my game lagging right now. I don't have a computer, so it's probably why. See, even on low graphics, I'm still getting lag. Well, there's a couple options to how to fix this. One of them is to go into, make sure you're next to the game of course, but one option is to go into your lights, so you go to workspace, so you should simply search for your lights, and then select them all, select all your lights there, and then simply disable shadows. Sure, this might fix the issue of lag, see it's much smoother now. There's one problem, now your shadows are gone, you don't have those nice shadows now. Feature lighting, that's the point of feature lighting, that is realistic shadows. So what can you do to optimize this so that it won't, you can still have realistic shadows, but it won't render the shadows of the lights that are far away. As you can see, the shadow's there. So this seam line here, these shadows are still being rendered, but no one's there, so what's the point of rendering? I mean, whatever lighting stuff it does, but I'm saying. So what you can do is you can simply turn off the shadows for all the lights that are down there. So that way, you can still see a shadow, you still get no shadow. But if you zoom out, your shadow for the avatar can be turned off. Roblox already does this, but it's not really as good, so yeah, so I'm going to teach you how to do that. So firstly, we're going to go into start a player script. We're going to make a local script. It's important that it's a local script because if it's a server script, it will simply turn off the lights for everyone and it will be glitchy as hell. Also, you can't get the camera on the server regardless, so you want to get the camera first, so you go to camera, make a variable, workspace, current camera. You also want to get the player, so local player, because game players, and get player, local player, and we'll also need one more thing, and that is the run service. Yep, run service. So that goes here. I'll have to put it all like that. So run service. You're like, why do we need run service for? What is run service? Well, run service is a service that is a service. So basically, it just runs services. Wait, no, yeah, we have to put in here. Sorry, run service. Okay, now we've got run service. Now we can do render stepped, which basically means that every frame that's rendered, it will fire this. So every time a render is stepped, basically it's sort of like a while true do loop, but it's more like it does it faster. And it just, if it errors, it doesn't like automatically break the game. It just continues to, despite the errors. So good. So now we want to get the magnitude. We want to get all of the lights. So what we're going to do, local lights equals game.workspace. Oh no, sorry, just workspace. We don't need to do that. Get descendant. So basically what this does is it's going to get every single object in workspace. So every single object, you'll get terrain. You'll get every single, let's say we put like a script in here, we'll get that as well. There's an issue, we don't want to turn everything off, do we? So what we want to do, we're going to do make a for loop. So for equals 1, hashtag lights, do. So now this will do this. Basically what this does is it makes a loop for every single one. We'll just do. So hashtag lights, what that means is how many lights. So when you get the standards, it will give you the table of every single object. And what this does is counts the table. So you'll go through every single one. So now we want to do, we're going to do if lights, do that because I is there. Yep. Dot class name equals, or name, you can just do name if you want to make its own specific lights to it. So for example, what is this class name? This is a surface light, so we'll do surface light. If it's whatever, you can do whatever. You can also do just name and just make it name every single light that you want to have shadows turned off for, or more optimized for. So yeah, for now I think the name will just work just fine. Then we'll find something called surface light, and if you have any attachments to any of the surface lights are in attachments, so this is a surface light as an attachment here as the parent of the surface light. And you also do and lights dot parent doesn't equal attachment parent dot class name doesn't equal attachment. Then, so if there is a surface light that is detected or gotten, and is the parent is an attachment, because then it won't work, because attachment uses a board position and stuff, and it won't work. But we can make it work if, yeah, okay. Anyway, then you want to turn, if it does that, yep, then lights, you want to get the magnitude between the two, so distance, whatever you're going to do. So then we do brackets, little brackets, the oval, I don't know what you call it, oval, that's what you call it, put those brackets in, and then, oh no, we want that, lights high dot position minus camera, so this is where camera comes in, dot position, no, you have to do C-frame dot position, there we go, dot magnitude. Then once you've done that, just you can just get the distance between the light and the camera C-frame position. So now this is where you do the distance. So if the camera is here, how far away do you, that's the camera, how far away do you want the lights to start to get the shadows? So this one, I think around, that's pretty good. That's pretty good. So then what you want to do, then what you want to do is you want to then get the distance. So this is around 24 steps. That should be good. So once you've done that, if distance equals less than 24 studs, then lights dot shadow. Oh no, we want to do lights dot parent dot position equals true. Else, then if it's not, then we'll make it false. So now, if we play the game, if I did this correctly, it should work. There we go. You can see if you get too far away, it turns off the shadows. This is a bit too close actually, so you can see the shadows are now optimized. You can see if we go too far away, it turns them off. See, it's much more smooth, so it's still a bit loud, but it's much smoother, as you can tell. And that's how you optimize your lights. You can of course change this distance to be whatever you like. And then you can also make this and then you can of course make this even longer if you want to. So you can turn off the lights at a far away distance. See, that's much better. You see, it's much less laggy now. More sort of it is. There you go, that's how you optimize your lights. Yes. Okay. Thank you for watching. Let me know if there's anything that you don't understand. I'll be sure to comment and help you. Bye bye.